Diagnosing seemingly random and simultaneous electrical failures in a home can be challenging, but a systematic approach will help. Several potential causes should be explored, ranging from external factors like utility issues to internal wiring problems and device failures. Firstly, consider an electrical surge. A sudden spike in voltage, possibly from nearby lightning strikes or utility equipment malfunctions, can damage electrical devices. Look for signs of surge damage, such as burnt wiring or blackened outlets. Secondly, investigate the possibility of a ground fault. A loose or faulty ground connection can cause an electrical fault that trips ground fault circuit interrupter outlets and breakers. Check the grounding system thoroughly for any disconnections or corrosion. Thirdly, examine the home's wiring for any faults. Loose wire connections or damaged wiring can lead to intermittent power outages or electrical shorts, potentially blowing out lights. Carefully inspect all electrical connections and wiring for any visible damage or loose connections. Overvoltage from the electric company is another significant possibility. If the transformer or overhead connections are loose or malfunctioning, it can cause overvoltage, leading to blown bulbs and tripped breakers. A recommendation has already been made to have the utility company inspect the transformer and overhead connections, and that is a good course of action to pursue. Defective devices themselves may be the culprit. Ground fault circuit, interrupter outlets, breakers, and light bulbs all have limited lifespans and can fail prematurely. Replacing the faulty devices is a necessary step, but it is also important to check for any underlying electrical issues that may have caused them to fail in the first place. It is worth noting that modern energy-efficient light bulbs are often more susceptible to surges and voltage fluctuations than traditional incandescent bulbs. Consider using surge protectors or voltage stabilizers to protect these bulbs, particularly in areas known for voltage instability. Beyond these primary aspects, there are other considerations. Determine if any appliances or devices are drawing excessive power, as this could cause voltage drops or overloads. Also, arcing faults can occur when there is a loose connection or damaged wires, causing momentary electrical spikes that can damage devices. And, lastly, moisture and corrosion can damage electrical components, leading to intermittent issues. Check for any signs of corrosion at connections or outlets. A systematic process of elimination combined with careful inspection and testing should help identify the root cause of these electrical problems. Remember to prioritize safety when working with electricity and consult a qualified electrician if needed. Let's delve into each of these potential causes with greater detail. Starting with electrical surges, these transient events can inject very high voltages into the electrical system for a brief period. Common causes include lightning strikes, switching of large loads by the utility company, and even certain types of equipment within the home that generate electrical noise. The effects of a surge can range from minor annoyance, such as a trip breaker, to catastrophic damage to sensitive electronic equipment. Surge protectors, ideally installed at the main electrical panel, can help mitigate the impact of surges by diverting excess voltage to ground. However, surge protectors have a limited lifespan and can degrade over time, so it's essential to inspect them regularly. Signs of surge damage can include the aforementioned burnt wiring, blackened outlets, a burning smell emanating from electrical devices, and unexplained malfunctions of appliances. Moving on to ground faults, these occur when current flows through an unintended path to ground, often due to insulation failure or accidental contact with a grounded surface. Ground fault circuit interrupters are designed to detect these faults and quickly interrupt the circuit, preventing electrical shock. However, a faulty ground connection can also cause nuisance tripping of ground fault circuit interrupters or, in more severe cases, a sustained ground fault current that can damage equipment. The grounding system is a critical safety feature of any electrical installation. It provides a low impedance path for fault current to flow back to the source, allowing the breaker to trip and clear the fault. A properly installed grounding system includes a grounding electrode, such as a ground rod or water pipe, connected to the main electrical panel. All metallic enclosures and non-current carrying parts of electrical equipment should be bonded to this grounding system. Check the grounding electrode connection for corrosion or looseness. Also, inspect the ground wires within the electrical panel and at outlets to ensure they are properly connected. Regarding faulty wiring, loose connections are a common cause of electrical problems. Over time, the vibration and thermal cycling of electrical equipment can cause connections to loosen, increasing resistance and generating heat. This heat can further degrade the connection, leading to a runaway effect that can ultimately result in a complete failure or even a fire. Damaged wiring, such as cracked insulation or exposed conductors, can also create electrical hazards. These conditions can result from physical damage, aging, or exposure to harsh environments. When inspecting wiring, pay close attention to connections at outlets, switches, light fixtures, and within the electrical panel. Look for signs of discoloration, melting, or corrosion. Use a screwdriver to gently tighten any loose connections. Be sure to de-energize the circuit before working on any electrical wiring. Overvoltage from the electric company is a less common but potentially serious issue. The utility company is responsible for maintaining a stable voltage supply to its customers. However, problems with the transformer or distribution network can sometimes cause voltage fluctuations. Overvoltage can stress electrical equipment and shorten its lifespan. It can also damage sensitive electronic devices. A sustained overvoltage condition can cause light bulbs to burn out prematurely, motors to overheat, and appliances to malfunction. If you suspect overvoltage, it's essential to contact the utility company immediately. They can monitor the voltage at your service entrance and take corrective action if necessary. Defective devices, as mentioned earlier, can also contribute to electrical problems. Ground fault circuits, interrupter outlets, and breakers are electronic devices that can fail over time. Light bulbs also have a limited lifespan, and some types are more prone to failure than others. When replacing a faulty device, it's essential to use a replacement that is rated for the appropriate voltage and current. Also, consider the quality of the replacement device. Cheaper devices may be more prone to failure. When replacing a ground fault circuit, interrupter outlet, or breaker, test it after installation to ensure that it is functioning properly. Energy-efficient light bulbs, while offering significant energy savings, can be more sensitive to voltage fluctuations than traditional incandescent bulbs. This is particularly true for compact fluorescent lamps and light-emitting diode bulbs. These bulbs often contain electronic components that can be damaged by surges or overvoltage. Consider using surge protectors or voltage stabilizers to protect these bulbs. Also, be aware that some energy-efficient bulbs may have a higher inrush current than incandescent bulbs. This means that they draw a larger amount of current when they are first turned on. This inrush current can sometimes trip breakers, especially if there are multiple energy-efficient bulbs in the same circuit. The electrical load on a circuit is the total amount of current that is being drawn by all of the devices connected to that circuit. If the electrical load exceeds the capacity of the circuit, it can cause the breaker to trip. Overloading a circuit can also damage the wiring and create a fire hazard. To determine the electrical load on a circuit, add up the wattage of all of the devices connected to that circuit. Then, divide the total wattage by the voltage of the circuit to calculate current. For example, if you have 6 100-watt light bulbs on a 120-volt circuit, the total wattage is 600 watts. The current is 600 watts divided by 120 volts, which equals 5 amps. Ensure that the total current does not exceed the rating of the breaker. Arc faults are a type of electrical fault that can occur when there is a loose connection or damaged wire. Arcing faults can generate intense heat and can ignite surrounding materials, leading to a fire. Arc fault circuit interrupters are designed to detect arcing faults and quickly interrupt the circuit, preventing a fire. Arc fault circuit interrupters are now required in many new homes. Corrosion can damage electrical components and lead to intermittent issues. Corrosion is caused by moisture and exposure to chemicals. It can affect connections, outlets, and other electrical components. Inspect for signs of corrosion, such as rust or discoloration. Clean any corroded connections with a wire brush or electrical contact cleaner. In addition to these potential causes, there are some other factors to consider. The age of the wiring can play a role. Older wiring may have degraded insulation or loose connections. The type of wiring can also be a factor. Aluminum wiring, which was used in some homes built in the 1960s and 1970s, is more prone to corrosion and loose connections than copper wiring. The climate can also affect electrical systems. Humid environments can accelerate corrosion, while extreme temperatures can stress wiring and components. Finally, the quality of the original installation can be a factor. Poorly installed wiring or connections can be more prone to failure. When troubleshooting electrical problems, it's essential to follow a systematic approach. Firstly, gather information. Talk to the homeowner to get a clear understanding of the problem. Ask about the symptoms when they occur and what devices are affected. Secondly, inspect the affected circuits. Look for any visible signs of damage, such as burnt wiring, blackened outlets, or loose connections. Thirdly, test the circuits. Use a multimeter to measure the voltage and current. Also, test the ground fault circuit, interrupter outlets, and breakers to ensure that they are functioning properly. Fourthly, isolate the problem. Disconnect devices from the circuit one at a time to see if the problem goes away. Fifthly, repair the problem. Replace any faulty devices or wiring. Be sure to follow all safety precautions when working with electricity. Lastly, verify the repair. Test the circuit to ensure that the problem has been resolved. In the specific case described, the simultaneous failure of multiple devices suggests a common cause. The fact that the ground fault circuit, interrupter outlets, and breaker failed at the same time points to a potential ground fault or surge. The subsequent failure of the underwater light bulb and all three garage light bulbs at the same time further strengthens the possibility of an overvoltage condition or surge. Given these symptoms, the recommendation to have the utility company check the transformer and overhead connections is a good first step. However, it's also important to investigate the other potential causes. Check the grounding system, inspect the wiring, and test the devices. If the problem persists, consider hiring a qualified electrician to perform a more thorough investigation. Remember that electrical work can be dangerous. If you are not comfortable working with electricity, it's best to leave it to a professional. Some examples of electrical tests that you may want to conduct include voltage tests. Use a multimeter to measure the voltage at various points in the circuit. This can help you identify voltage drops or overvoltage conditions. Also, conduct continuity tests. Use a multimeter to check for continuity between different points in the circuit. This can help you identify open circuits or short circuits. Insulation resistance tests can be performed by using a micrometer to measure the insulation resistance of the wiring. This can help you identify damaged insulation. Ground impedance tests use an impedance meter to measure the impedance of the grounding system. This can help you identify problems with the grounding system. A systematic approach today knows the symptoms of the electrical system, and the readings you obtain using the testing tools mentioned above will guide you toward identifying the cause of your issue and the correct corrective action to make. When working with electricity, always follow these safety precautions. To energize the circuit before working on any wiring or devices. Use insulated tools. Wear safety glasses. Work in a dry area. Never work alone. If you are not comfortable working with electricity, hire a qualified electrician. Some useful resources include the National Electrical Code, the Underwriters Laboratories, and the Occupational Safety and Health Administration. The National Electrical Code sets the standards for safe electrical installations. Underwriters Laboratories tests and certifies electrical products. The Occupational Safety and Health Administration provides information on workplace safety. Specific code references, such as National Electrical Code 210.8 regarding ground fault circuit interrupter protection and National Electrical Code 250.50 concerning grounding electrode systems, can provide further guidance. Always refer to the latest edition of the National Electrical Code for the most up-to-date requirements. Remember that electrical safety is paramount. By following these guidelines and taking appropriate precautions, you can safely troubleshoot and repair electrical problems in a home. For example, let's say that you suspect a loose neutral connection is causing voltage fluctuations. You could use a multimeter to measure the voltage at different outlets while turning on and off various appliances. If the voltage fluctuates significantly when an appliance is turned on, it could indicate a loose neutral connection. To further investigate, you could turn off the main breaker and then carefully inspect the neutral connections in the electrical panel and at the affected outlets. Look for any signs of looseness, corrosion, or damage. If you find a loose connection, tighten it securely. After tightening the connection, turn the main breaker back on and recheck the voltage at the outlets to see if the problem has been resolved. Alternatively, suppose you suspect a ground fault is causing a ground fault circuit interrupter to trip. You could use a ground fault circuit interrupter tester to verify that the ground fault circuit interrupter is functioning properly. If the ground fault circuit interrupter tester trips the ground fault circuit interrupter, it confirms that the ground fault circuit interrupter is working. However, it doesn't necessarily identify the source of the ground fault. To find the source of the ground fault, you could systematically disconnect devices from the circuit one at a time until the ground fault circuit interrupter stops tripping. Once you've identified the device that is causing the ground fault, you can inspect it for any signs of damage or insulation failure. You can also use a multimeter to measure the resistance between the device's conductors and its grounding wire. A low resistance reading would indicate a ground fault.